Good morning, boys. Now we have completed the very important topic light, reflection and refraction. Okay. Now we are going to start the next topic, that is electricity. You know, electricity is a very important form of electrical energy. It is an electrical energy which plays a very important role in our modern society. We need electricity for lighting, for charging our devices, in our school, in our homes, in industries, in the streets, everywhere we need electricity. We cannot think life without electricity. So life has become an integral part of our life. So it is very essential to learn about the origin of electricity and its applications, how one can control the electricity, regulate the electricity. So it's all very, very important. So in this particular topic, you are learning mainly some important aspects of electricity. That is, you are learning what is electric current and what is electric circuit. Second thing, what is the electric potential and potential difference. Electric potential and potential difference. Then third one, electric circuit and circuit diagram. What is the meaning of circuit diagram? What is its importance? Fourth one, very important law which relates the current with voltage, Ohm's law. And what is the meaning of resistance, Ohm's law and resistance. Fifth important point, factors on which resistance depends. Factors on which resistance depends. Very important. Sixth one, resistance of a system of resistors, combination of resistors. Resistance of system of resistors. The conductor which has a resistance is called as a resistor. Okay, we will be having different system of resistors, series combination, parallel combination and so on. So that is the resistance of a system of resistors. Then what is the heating effect of electric current? Heating effect of electric current and electric power. Heating effect of electric current, like the electric iron, electric oven, microwave oven, heating effect of electric current, electric geyser. And the last one, power, electric power. So these are the main aspects that you are learning in the topic. So first let us understand what is the meaning of electric current and what is the meaning of electric circuit. You are all aware of the air current, water current. Now heavy blow of wind is seen. So this constitutes current of air. So that is air current. Current of air current. In Kannada we call it as pravaha, vayu pravaha, air current. In the same way, water current. When there is a flood, water flows in all the possible areas. When the river flows, it is the water current, jala pravaha. Flow of water we call it as water current. In the same way, if there is a flow of electric charges through the conductors, then we call it as electric current. Then what do you mean by flow of electric charges? On what conditions the charges flow in a conductor? What do you mean by conductor? So conductor is the one through which the current flows, like copper wire, aluminum wire, iron rod. These are all electric conductors through which the current can flow. So when do these charges flow? First of all, what is the meaning of charge? So charge is a characteristic unit of matter by means of which matter experiences electric forces. What is charge? Charge is a characteristic unit of matter by which electric forces can be It's a characteristic unit of matter by which electric forces of attraction or repulsion be exerted between the matter particles. When you take a comb and rub it with dry hair, bring it near the pieces of paper. The rubbed comb attracts the pieces of paper. It is because of the charges that are developed by rubbing the comb. This is what you have learned in lower classes. So there are two types of charges, negative charge and positive charge. Two types of charges. Negative charge that is charge carried by an electron. Charger of an electron. And positive charge. Charge, for example, charge carried by a proton. So charge is a characteristic unit of matter by which electric forces will be exerted between the matter. Because of these electric forces, if positive charges are brought close to each other, there will be force of repulsion. If positive and negative charged bodies are brought close to each other, there will be force of attraction. So like charges repel each other, unlike charges attract each other. Like means same kind of charges, negative charges, if they are brought to each other, there will be force of repulsion. Positive charges, if they are brought close to each other, there will be force of repulsion. So such same kind of charges are called as like charges. If opposite charges are brought each other, if oppositely charged bodies are brought close to each other, there will be force of attraction. So such forces are called electric forces. So the electric forces originate because of the charge. Now basically in a conductor, like it may be copper, it may be iron rod, or it may be aluminum, it may be any good conductor like silver, gold. It will be consisting of large number of charges. So you know, when these charges are allowed to flow in one particular direction, then we say that there is current being established in that conductor. How is it possible? Just think, there is a pipe, there is a water pipe, horizontal water pipe. Think that this is a horizontal water pipe. Water has to flow from this end to this end. It has to flow along the horizontal pipe. Water cannot flow on its own because it is a horizontal plane surface. If there exists a pressure difference, if there is a high pressure from this side and low pressure from this side, then what happens? The water flows from high pressure to low pressure. So pressure difference is required. Or if you think of a slope, water flows from higher level of height to the lower level of height through this slope. When there is a slope, water flows from higher level to lower level. In the same way, when there is a difference in temperature, the heat flows from hot body to the cold body. The heat flows from hot body to the cold body, means heat flows from body at higher temperature to a body at lower temperature. In the same way, the charges also flow from one point to another point when there is a difference in potential. What is that meaning of potential? That we will understand a little later. When there is a difference in amount of charges across the conductor, suppose this is a conductor, like let us say this is an iron rod. If there is a difference in number of charges, if at one side suppose there are 100 charges and another side there are only 10 charges, so this difference in charges make the charges to flow from one end to another end, from a higher potential to lower potential. So in a rough way I can say the point of higher potential is that point where there is high amount of charges are present, and point of lower potential is that where there is less number of charges are present. So charges flow from higher potential to lower potential. So for the flow of charges there is a requirement of potential difference. We will define what is the potential difference little later. So this flow of charges constitutes what is called as electric current. So electric current is in a simple way, it is defined as rate of flow of electric charges. Rate of flow of, you can say amount of charge, rate of flow of amount of charge, electric charge across a conductor. It is called as electric current. In a more specific manner, this can be also defined as the amount of flow of charges flowing per second per unit cross sectional area. So it can be also defined as amount of electric charge, flowing a cross section area, flowing a cross section area. Cross section area means the area perpendicular to a perpendicular area perpendicular to a wire. So that is what we call as cross section area. So how much of charge is flowing per second across a cross section area per second is called as electric current. Is called as electric current. This electric current is denoted by I. So I is also equal to charge flowing per second. So I is equal to Q by T, where Q is the amount of charge flowing across a cross-section area and T is the time taken. Using this equation, we can find out what is current, electric current. Electric current is equal to Q by T. Now, what is the unit of charge? Let us learn about the unit of charge. The SI unit of charge is coulomb. C-O-U-L-O-M-B. Coulomb is the scientist who formulated a law between the charges. He explains about the force of attraction between the force of attraction between unlike charges and force of repulsion between like charges. That is learned as Coulomb's law of electric interaction, Coulomb's law of electric forces, which you are going to learn in 12th standard. So, in his honor, the assignment of charge is taken as Coulomb. 1 Coulomb is written as capital C. Capital C is the notation for Coulomb. Then what is 1 Coulomb of charge? You know, in a conductor, you will find large number of electrons available. What do you mean by electrons? Electrons are the charge carriers which carry negative charges. Electrons are present in an atom outside the nucleus. These electrons revolve around the nucleus. The outermost orbit electrons which are available in an atom are called free electrons. They are having high energy. So these electrons are responsible for the electric current in a conductor. Okay. Before inventing these electrons, it was assumed that the flow of positive charges constitutes electric current. So even now also we take the direction of flow of positive charges as the direction of electric current. So later on electrons were invented and it is discovered that it is the flow of electrons which constitutes electric current. The flow of electrons, if it is from right to left, suppose this is the conductor, if the flow of electrons is from right to left, then the direction of electric current is always from left to right. So that is called as conventional direction of electric current. So conventional direction of electric current is conventional direction of electric current is opposite to the flow of, opposite to the direction of flow of electrons. It means if electrons are moving from right end to the left end of a conductor, it is as good as assuming the positive charges are moving from left end to right end. Positive charges are moving from left end to right end. That is the meaning of conventional direction of electric current. That is the direction of motion of positive charges. Direction of motion of positive charges is the conventional direction of electric current. Is the direction of electric current. Direction of electric current. Now let us learn something about 1 Coulomb of charge. What is that 1 Coulomb of charge? How many number of electrons constitute 1 Coulomb of charge? Right? It is, suppose n is the number of electrons which constitute 1 Coulomb of charge. Now we should know what is the charge on each electron. We know charge on each electron. It is fixed. Charge on each electron, it is denoted by small e. It is a negative charge. Small e equal to 1.6 into 10 raised to minus 19 coulomb. 1.6 into 10 raised to minus 19 coulomb. And if the total charge we want 1 coulomb, if we want to have 1 coulomb of charge, how many such electrons are required to constitute 1 coulomb of charge? So that can be found using this simple equation. Q is equal to Ne, where N is number of electrons and E is charge of each electron. That constitutes the total charge Q. Here, if Q is equal to 1 coulomb, E is equal to 1.6 into 10 to the power of minus 19 coulomb. Then what is the number of electrons? What is the number of electrons? Then M is equal to Q upon E. M is equal to Q upon E. So this gives us 1 coulomb. We want to construct 1 coulomb of charge. How many electrons are required? 1 coulomb divided by 1.6 into 10 raised to minus 19 coulomb. That is charge of each electron. So coulomb cancels. So this you can write it as 100 divided by 16 into 10 raised to 18. After simplification, 10 raised to minus 19 goes to the numerator. Then you simplify it as 100 by 16. So that we can write 16 6 are 96. 6.2 into 10 raised to 18 number of electrons. So these many number of electrons together constitute 1 coulomb of charge. Therefore, 1 coulomb of charge is equivalent to charge carried by I can take easy to remember 6 into 10 raised to 18 electrons. If it is electrons. If you want to have 1 coulomb of positive charge, then you can think of 6 into 10 raised to 18 protons together constitute 1 coulomb of positive charge. This is the meaning of the assignment of charge. So 1 coulomb of charge contains 6 into 10 raised to 18 number of electrons. That is the meaning of 1 coulomb of charge. Now let us learn what is the meaning of electric circuit. What is electric circuit? The path of the flow of current is, in simple manner we can say, electric circuit. So it is also the continuous and the path of continuous flow of charges is called as electric circuit. You can just write what is electric circuit. The path of the flow of current, that constitutes electric circuit. It is actually the closed path, the continuous and the closed path. The continuous and closed, continuous and the closed path of electric current is called electric circuit. To give simple electric circuit, example of electric circuit you are already doing, the torch. The torch requires cells. Let us say it is a torch having 2 cells, batteries. So when these cells are connected in a proper direction, in a proper manner, and when you close the torch, it requires a switch. When you switch on, then the bulb of the torch glows. So it is the path of the electric charges flowing from the source cells to the bulb through that connecting conductors. So the charges flow from that connecting conductor from the electric batteries, from the cells to the bulb, and that closed path, that continuous and closed path of electric current is called as the electric circuit. When you switch on, then only the bulb glows. When you switch off, the bulb stops glowing. When it is in switch off mode, it means the circuit is broken. The circuit is open. Open circuit. What do you mean by open circuit? When you switch off, there is a disconnection between the source of the current and the conductor connecting the bulb. So that disconnection is called switch off. Switch on means there is a linking, there is a connection between the source of battery, the cells and the bulb. When they are connected with the help of conductor, then it is called switch on. The circuit is closed. So there are two types of circuits: closed circuit and open circuit. Closed circuit means switch on. When it is in switch on mode, then there is a flow of charges through this closed path of electric current, that is called the closed circuit. Switch off. This is switch off. There is no link, there is a disconnection. So just to draw one simple diagram, suppose these are the two cells, right? And here is a bulb. Here is the bulb. Symbolically, the bulb is drawn like this, and here is a switch. Now it is in open circuit. When you see this positive terminal of the battery is shown by longer line and negative terminal of the battery is shown by shorter line. So when you close this circuit, closed circuit is shown by tapping the key. This is one way. Another way of showing the circuit is, suppose this is also another way of showing the key. This is called key. This is also key. Or another way is called as switch. This is bulb. The moment you close this, then what happens? The charges, positive charges flow from positive terminal of the battery, goes through the bulb, and then they flow back down, they flow back to the negative terminal. That's how the circuit is closed and the bulb glows. So this is called a simple circuit. You have learned already in lower classes. Simple circuit consists of cells, source of electric current, battery or cells, then a conducting wire or conductors, then a bulb and a switch. Bulb, switch, battery and connecting wires together constitutes a simple circuit. So simple circuit is just a continuous and closed path of electric current, that is called as simple circuit. And you see the direction of current is from positive terminal to the negative terminal. The flow of positive charges is from positive terminal to the negative terminal. This is called as the direction of electric current. Whereas the direction of electrons is actually from negative terminal to the positive terminal through the external circuit. So the electrons actually move from negative terminal. So negative terminal is the source of electrons. So the negative terminal, from the negative terminal, electrons flow and reach the positive terminal. But the direction of electric current is opposite to the direction of flow of electrons. The direction of electric current is opposite to the direction of flow of electrons. That's what we take it as conventional direction of electric current. Okay, we'll continue this in the next session and we'll learn more. In the next section we'll learn what is the meaning of potential and potential difference. How potential difference is required to establish current in a conductor. Thank you. Have a nice day.